Hello everyone. Today I'll be showing you guys how to do the esterification reaction. So we use this to make esters. So let's go ahead and start. First of all, what you're going to need is you're going to need a carboxylic acid. Then you're also going to need an alcohol. And this will always have the R group that you want to attach, to your ester. And then also we're going to need some acid. This reaction is acid catalyzed. So let's go ahead and show you guys the mechanism for what's going to happen. Before I show the mechanism, I'm just going to go ahead and show the product that I expect. This is the product that I expect. This is called an ester, right? And I'm using a carboxylic acid and an alcohol and an acid to go ahead and start this mechanism. So first of all, the acid is going to be captured by this nucleophilic oxygen on the carboxylic acid. So you're going to have an OH plus, right? And an OH right there. Well, this oxygen does not like to be positive, so it's actually going to remove a double bond, the double bond between it and the carbon, and it's going to have a neutral charge. So you're going to have two hydroxyl groups, but you're also going to have a carbocation, right? There's a carbocation right there because there used to be a double bond around this carbon, so it used to have 1, 2, 3, 4 bonds, and now it only has 3. So this is the part where the alcohol comes in. The alcohol has a nucleophilic oxygen, which on its own it's not a very good nucleophile. Alcohols usually are not very good nucleophiles, and that's actually why we went ahead and we added the acid, to make this more nucleophilic so that we can ensure that this reaction will go forward. So the alcohol will join in OH, and the alcohol. So let's go ahead and just draw this, right? Okay, I'm going to zoom in here a little bit. And this has a plus charge on it. This oxygen has a plus charge. Also, keep in mind that we haven't removed the acid, so we still have acid floating around. So this hydrogen plus is going to be captured by either one of those hydroxyl groups, right? Oops. Either one of those hydroxyl groups, it doesn't matter, but it's going to get captured. And right? So here's something that I want you guys to keep in mind. Since I have two oxygens on this molecule that are both positively charged, one of them is going to be a leaving group. Now, which of those two would prefer to be the leaving group? Is it the OH2 molecule or is it this alcohol right here? Well, it's going to be this OH2 group. Why? Because when it leaves, it's going to be a stable water molecule. It's going to be an H2O molecule, which is very stable, right? So this is going to leave at the same time that these electrons are going to come in and form a double bond. So we have something that looks like this. So an O double bonded. This group is gone. So now I have, hold on one second, let me see something. I think I lost, yes, I lost a carbon in here while I was drawing this. Okay, sorry. So this oxygen is gone, so now I have this carbon and this carbon. And then OH. And actually, what's going to happen is this is not going to be positively charged. The alcohol still exists in solution, so I'm going to have an O, right? So this is going to capture my hydrogen, which is going to donate its electrons to this oxygen. And I'll draw it a little bit better for you guys to see. So this is my double bonded O. This is my O with that chain. And this is my carbon, right? So this is the same as what we expected up here, which is that. So this is it. This is a very simple reaction. It doesn't take much at all. And thank you guys for watching. I hope it all makes sense. And like I said, this is a very simple reaction, so I'll see you guys later when I make a second video. Alright, bye.